So second part, looking at graph equations of the form cos x equals k. Notice that the formula is different now. No longer 180 minus PV as with the cos graph, but it's just minus PV. That's not surprising because, of course, the cos graph is different. Okay, it's got this symmetry about the x-axis. It doesn't start at 0, 0, it starts at the top, so we wouldn't expect the formula to be the same. Again, as before, you could just use the graph to solve a trig equation. It would involve knowing the graph reasonably well, and you need to know the graph well anyway. So you can use the graph to read, to interpret and find the other values. Now, when we talked about principal value. When you work with a principal value with a cos, you'll find the answer that the calculator gives you, the principal value, instead of lying between 0 and 90, it lies between 0 and 180. So your calculator will give you a solution between 0 and 180. So let's just say we've got the equation cos x equals half this time, as we did before. Cos x equals half. Now in this case, our principal value is equal to arc cos of a half, which is equal to 60 degrees, which is this angle here. Okay, now in this case, the other value will, unlike before, is minus the principal value, so minus PV, which is minus 60, which is this one here. So we get our two solutions, 60 and minus 60, and then we just simply add and subtract multiples of 360 for that to find the other solutions. Imagine again that we wanted solutions between, let's just say this time we wanted solutions between minus 360 and 360. Okay, we can see the solutions on the graph. We could probably find them, but let's just use this method with the general angle formula and present it properly. So we've got x equals to the principal value, which is 60 degrees, plus any multiples of 360 minus any multiples of 360. Okay, so we've got, so put it into formula, PV plus 360n and minus PV minus 360n. So we've got x equals 60 x equals 60 as one of the solutions and minus 60 as the other. Now if I add 360 to that, I can add 360 to that, I'll get 420, but notice that I not particularly interested in the 420. If I add minus 60 to 60, I get the 300, which of course I am interested in, the 300 answer. Okay, have I got all the solutions here? Well, no, because I've got another solution of minus 360, which is here, and if I take away 360 from this solution, I get minus 300. Okay, minus 300 there. So my solutions are x equals to minus 300, minus 60, 60, and 300. We can see them on the graph here again. I can see them on the graph here again. We've got the 60 degrees that the calculator gives us, the principal value. If we added 360 to that, we get this one, but we weren't particularly interested in that one, the 420. If we took away 360, we get this one, which we were interested in, that's our minus 300. Okay, looking at the other branch, we've got minus 60 there. And to get the other solutions, we could take away 360, which would give us that one, but that's outside our range because we don't want to be below minus 360. We're not being asked for those. And then we could add 360 to that, which gives us our 300 there. And say all of them could be got from the graph alone, but if you can remember these formulae, that makes life a lot easier and a lot quicker. Okay, now let us suppose, if you want to pause for a moment to ask your own question, or if we think of another question. Cos x equals minus 0.1, and let's just say we're going between minus 360 and 360 again. It might be worth pausing the tape and seeing if you can come up with those solutions now and playing again when you've got your answer. Okay, so this is how it works. We've got x equals to, we work out the principal value by doing arc cos of minus 0.1. Okay, arc cos of minus 0.1. (95.7 degrees). So looking at our formulae, we've got x equals to that number, which is 95.7. Take away this number, 95.7, plus or minus lots of 360. Okay, so I need to find the solutions which lie in this range. So obviously we've got the 95.7 does lie within the range, but if I add 360, that's going to go outside the range. So I'll take away 360 because I want to be, that one will be more than minus 360. So I get minus 264.3 for our other solution on that branch. Turn into this branch, I get minus 95.7. Okay, if I take away from that, I'm going to be outside our range. But if I add 360, I'm going to get another solution which I am requiring. So that's 264.3. So writing out our four solutions within the range we're being asked for, we've got x is equal to minus 264.3 minus 95.7 and 95.7 and 264.3. Four solutions that lie within our range that we require.